The inverse square law is a proportionality like inversely proportional or directly proportional proportionalities that we've gone over already. It's most related to the inversely proportional proportionality we went over last week, where one variable was inversely proportional to another variable, which meant that when one went up, the other went down. And we can see that that's taking place here. So the inverse part is still the inversely proportional part. When one variable goes up, the other goes down. We can see that the two variables we're talking about here is force and distance. An intensity and distance, or a force and distance, is what we're talking about for something that would relate to the inverse square law. The inverse square law relates to gravitational force, electrical force, magnetic force, intensity of light and sound. All of these things follow the inverse square law. The inverse square law tells us that the distance between two objects that share these forces or intensities, for example, if we're talking about gravitational force, then the distances between the two planets or the spaceship and the planet. If we're talking about electric force, it could be the distance between an electron and a proton. If we're talking about sound or light, it is the distance between the emitter of that sound or light and the receiver of that sound and light. So all these things the inverse square law relates to. And we've already said that the force is inversely proportional with the distance between those objects, and that makes sense if you think about things like gravitational force, light, and sound. If you have two objects and the distance between them begins to increase, then that sound intensity or that gravitational force, whatever the force is, begins to decrease. So as we spread two objects apart, the forces decrease between those two objects, whereas when we get those two objects closer together, the distance decreases, then the force will increase. So gravitational force increases as the two planets would get closer to each other. The sound increases the closer the emitter is to the receiver. The big thing about the inverse square law that makes it different than the inversely proportional and what gives it such a unique quality for all these laws is that all these forces and intensities spread out in 3 dimensions. So if we have a 3 dimensional cone coming out from, or maybe like a ball, if you could imagine a ball of gravitational force coming out of one planet and going to another planet. So if we had a ball that was a planet and we have 3 dimensions in space, so there's one dimension, there's another, and then we have one coming out here. And if we can think of a cone or a ball around here in 3 dimensions, and this gravitational cone gets bigger and bigger, then as we get farther out, that gravitational force, that sound, that light gets spread out wider and wider. So that same force, that same sound is spread wider and wider. And so the farther we get from it, the more that it's spread out in the ball. And the surface of a ball can be described in a 2 dimensional area, where this 2 dimensional area is the surface of the ball. Big ball coming out here. So 2 dimensional areas can be described by squares of distance, and this force is spreading out farther and farther that we get away from this object. And so it gets weaker and weaker by the square of the distance because of this 3 dimensional spreading out. So the inverse square law is not only an inversely proportional relationship between the force and the distance between two objects, but it's also goes down by the square of that distance. So it gets lower and lower or greater than greater by the square of the distance. So for example, if we had two objects that were, let's say, here's one object and here's the second object. And let's say that they are 2 meters apart and that the force between them, and whatever this force is 4 newtons of force, whatever this force is we're talking about. And so we then move object 1 over here, and this is our new object 1. So our new object 1 is now 4 meters away. And so what happens is we've doubled the distance. If this were just inversely proportional linearly, like it usually is, then we would have multiplied the distance by 2. The distance would have gone up by 2. So if the distance is going up, distance is increasing, then the force is decreasing. But the force isn't decreasing by 2 like it would if it was linear. The problem here is that it's squared. So the distance has increased by 2, but the force has gone down by the square of that increase. So if we increase the distance by 2 times, then it decreased by 4 times the square of 2. So the inverse square law, the part that makes it unique is the fact that it's by the square of the distance. It's a very important part of how sound and light affect things. Their intensities decrease very quickly, drop off by the square of the distance from their emitter.